All right, gang, so picking up where we left off. Expression evaluation practice. I believe this is where we left off. So if we have x is equal to 10, y is equal to 4, and z is equal to 6.0, we're going to use operator precedence. If you remember, operator precedence means that anything inside parentheses has to be evaluated first, forces the order of operation. Then, once all the parentheses are dealt with, multiplication and division and modulus happen before anything else, above addition and subtraction. So we're going to look at this and we're going to remember one more thing, which is that an integer divided by an integer is a special case of division called integer division, which results in an integer, meaning it's rounded down. 3 divided by 2, if they're both integers, is not equal to 1.5, it's just equal to 1. Okay, so let's look at this. Z plus 10 divided by 4. Actually, I think before I started messing with this, this was x divided by y, right? But as we go, I'm going to fill these values in. 10 divided by 4. Why am I doing this first? Because it's within the parentheses, but inside the parentheses I still have to follow the operator precedence. 10 divided by 4, they're both integers. That means divide and round down. So 10 divided by 4 is 2.5, which is 2. Or something like that. I may have gotten that wrong. Anyways, I know it's 2. Alright, so we still have these parentheses to deal with. Got to do that. So z plus 2, well, z is 6.0, so 6.0 plus 2 is 8.0. The 0.0 is important. Why? Because now we're not dividing an integer by an integer, we're dividing a floating point value by an integer. All right, there we go. So since there's no integer math involved, since it's floating point, then we're not going to round down. So 8.0 divided by 10 is 0.8. Now and only now can we do the last multiplication. 0.8 times 2 is equal to 1.6. That makes sense. Now this one's weird, because just like 0 divided by x is 0, 0 modulus x is 0, because x means remainder, right? And so if you divide something into 0, the answer is 0, with a leftover of 0. So doing the parentheses first, that's a 0, that's a 0, and it's pretty clear that this is 0 plus z plus 0. And if z was 6.0, then that means that's 6.0. Okay, so increment and decrement. That's the increment operator, plus plus. That's the decrement operator, minus minus. It means the same thing as x equals x plus 1. X minus minus is the same thing as x equals x minus 1. Now if you like, you could keep using a Python style version. X plus equals 1 means the same thing as the other two. And x minus equals 1 means the same as the other two. But as they know, proper style dictates that increment and decrement operators should be used. They want you to do this. I tend to agree. But you need to keep this one in the back of your mind, because what if you wanted to add 2 to it, right? You can't do x plus plus 2. Instead, you have to say x plus equals 2. So keep that one in mind, but then use that one. Unless you're going to modify it by more than 1, right? There is no x, there is no x star star or x slash slash, meaning, I don't know what it would even mean. Increment just means add 1. Decrement just means subtract 1. Compound assignment. I just mentioned that. X plus equals 3 is the same as x equals x plus 3. X minus equals 4 is the same as x equals x minus 4. What if you multiply that, X times equals 4 is the same thing as x equals x multiplied by 4. Same for division. X slash equals 4 is the same thing as x equals x divided by 4. And lastly, modulus. X modulus equals 4 is the same as x equals x modulus 4. Right? Proper style dictates that compound assignments should be used instead of things like that. Maybe you think that's clear to read. Maybe you think x equals x plus 3 is clearer than x plus equals 3. If you do, you could go for it. However, I'd recommend that you just accept it and go ahead with x plus equals 3. Trace this code fragment. And I'm not going to bother with tracing. Oh, I guess I will. Just this once. Tracing is when you pretend that you are the computer. So we have several variables. We have A and B. A gets set to 4. And B gets set to 6. You can't read that. Let's zoom in. And then later on, we declare another one, C, which is equal to 2.0. The next line of code subtracts B from A and puts it back into A. So that A equals A minus 6. 4 equals 4 minus 6. Well, that's negative 2. So A changed to negative 2 on that line. Go to the next line. B minus minus. That subtracts 1 from B. B is no longer 6. B becomes 5. C++. Well, that's going to change the value of C. It's going to increment it. So from 2.0 to 3.0. And then C times equals B. That means C equals C times B. So 3 times 5 is 15. And then when they print them out, A plus B plus C is equal to A plus B plus C. Well, 15 plus 5 is 20 minus 2 is 18. If I'm correct, if I did my math right, then the final answer should have been 18. Do they show us the answer? Yeah, it seems like sometimes they do, sometimes they don't. Well, I hope it's right. That's what tracing is. It's easier done if you have an Excel spreadsheet, if you have a lot of variables. Every time a variable changes, you write its new value down, and you skip to the next line. If the variable stayed the same, there's no reason to write it down again. I mean, I could have written minus 2, minus 2, minus 2, minus 2 there, right? But it's better just to write a new value every time it changes. In writing a program, you'll sometimes need to convert a value to a different data type. What do I mean by that? If I'm going to do some math, system.out.println, and I want to divide 4 by 3 for whatever purposes, it's going to say that that's equal to 1. What if I didn't want it to equal 1? What if I really wanted it to equal, 1.33333? And yeah, sure, I could make that 4.0, right? But what if these were variables that were coming in? Int x is equal to 4, int y is equal to 3, and then double z is equal to x divided by y. So the way these things work is it processes everything before the equal sign, and only then is that value copied across the equal sign into the resulting, variable that is going to contain its value. So this is integer math. 4 divided by 3 is going to be 1, and 1's going to go in there, and then if we print out the value of z, it's going to print out 1. What if we did not want it? We wanted it to say 4.333. We did not want to allow integer math. Well, this wouldn't fix it. In fact, that'd be a syntax error, right? Storing 4.0 in that line, that would be a syntax error because we cannot store anything with a decimal point in an int. Unlike the C++ language where you can get a little bit more loosey-goosey and it would go ahead and convert it to an integer, can't do that in this language. But we can convert this x to be a double or a float so that the math works correctly. Here's what we do. We say, please take x and convert it to a double temporarily, just so that I can do this math. Now it doesn't actually change the value of x, but for the purposes of this statement, x has been converted from an integer to a double. So now it's equal to 4.0, and 4.0 divided by 3 is 1.3. So that's what it would print there. Or what if you need to do vice versa? What if you have a value stored in a double, but you need to put it into an integer, right? So you say double pi, can I type? Double pi equals 3.14159. And then for some reason you wanted to put that into x, which is an int. If you do this, that's going to be a syntax error. It will not compile. If you do this, if you say int parentheses, pi in parentheses, it goes, okay, you know what you're doing. You know that it's going to get rounded down to 3. It's not my fault if that happens. So the compiler goes ahead and provides a code that casts, that converts that floating point value to an int. So if we have our change in dollars, change for some reason is stored in a floating point, but we want to represent it in terms of an int, then we could cast it to be an int. Why would you do that? Well, what if change equal 4.7? But you wanted it to be dollars. Well, you take that 4.7, it converts it to an int, which means it rounds it down, and so it becomes 4, right? That's how many dollars we get is 4. Then we'd have to figure out how many pennies. That'd be a different problem. If you ever need to cast more than a single variable, you just put parentheses around the whole thing, right? Payment minus cost. It costs $10. Excuse me. You pay $10. It costs $7.50. Your change is $2.5. But you want to find out how many bills that is. You take that 2.5, cast it to an int, which will round it down, and now change in dollars is equal to 2. Another character type. It holds a single character. It's declared with single quotes, just like this. My first initial is single quote M. Now, unlike Python, where you could use double quotes and single quotes, apostrophes and double quotes, indiscriminately, it didn't change the way it worked. In this language, if you're using the char data type, you have to use single quotes. No way around it. So then when this printed out, it would print hello, MLK, followed by an exclamation mark. If you wanted spaces between the initials, then you'd have to add them there, right? I could do that. I could add a space there, right? Concatenate a space into there, and then it would print M space LK. What is a char underneath it all? Char underneath it all is just a byte that contains an ASCII character. You could go to ASCIItable.com and find out what the ASCII value of a capital A is, and it's 65. So if you cast that B to an int, it would say that it was a 66. And I'll show you what I mean. Leave our elixir G. Alright, so they seem char CH is equal to A. Now that's a syntax error because I used double quotes. So I'm going to change that to single quotes. Double quotes are strings, single quotes for characters. Now let's cast that as an integer. And then if we print out value, or if I set a breakpoint, stop it at that point, find out the value, I'm going to do it that way this time. How do you set a breakpoint? You come and you click on the line number, it puts a little red thing there. And then when you run it, you click debug, debug project. Of course, it has to compile the code and all that, so the first time I run it, it's going to take a little while. And then it runs it, and the green line indicates the line where it stopped, right? And it stopped at my breakpoint. So if I hover my mouse over CH, it tells me that the character is in fact A. Very good. I'm going to skip this line. Well, I'm going to execute this line by issuing a step over command. How do I do that? Up here. Step over expression. The one that looks like a bounce, right? Yellow line is bouncing. So I click that, it executes that line, and then I can move my cursor over value and see that an A is actually 65. Well, what the heck, where did that come from? Also, I can come down here and I can see all the values. My character is equal to the value A, sort of surrounded by single quotes, but the value variable, which is an integer, is equal to 65. Where does this come from? Why is A equal to 65? You probably know this. You probably know what the ASCII table means. But if I load up ASCIItable.com, or if I just Google it, right, then what we will see is that an A is coded by the value 65, and the B is coded by the value 66. So if you typed in a string that equal to BAD, to spell bad, BAD, then in computer's RAM, B is a 66, A is a 65, and a D is a 68. So that's what the computer sees, and it's, you know, it just has to have some way of treating your text as numbers, because ultimately that's all a computer wants to deal with is numbers. And when I say wants to, that's ultimately all it can do. You know, everything is a number underneath it all, a series of numbers. Your images, your games, your your music files, your text files, Word documents, etc. It's all got to be represented in memory as numbers. That's what it boils down to underneath. Escape sequences. Sometimes you want to do something a little bit special, like you want to put a blank line, or if you want to put a tab, or if you want to print a double quote in your message. Well, what do I mean by that? Going back to NetBeans, I'm going to remove the breakpoint. It's kind of colorizing all this. Well, I'm done debugging, so I'm going to press the stop sign up here, finish the debugging session, the stop square. All right, get rid of the breakpoint, so I'm going to click on line 21 again, get rid of the red square. Okay, so what if I wanted to do this? System.out.println, parentheses, quote, CH equals, and for some reason I wanted double quotes around it. Okay, I'm going to come up with a name, you know, Eminem. My name is Slim Shady. My name is double quote Slim Shady, in double quote, in parentheses, semicolon. And apparently I have too many semicolons and stuff like that. But anyways, this is a syntax error. Why? Well, okay, maybe I needed another double quote there. No, what's happening is it's treating this as one string, and then it's seeing this word slim here just out of nowhere, right? And there's no variable called slim, and even if there was, that would be invalid syntax. So in order to print a double quote, we need an escape sequence. What's an escape sequence? It's something preceded by a backslash, the key above the enter key, not the forward slash, which is below the question mark, followed by a letter or a symbol. So that right there means output that as a double quote. Output that as a double quote. And the compiler is smart enough to know now that this quote right here does not actually end the string. Right? That's just an escape sequence. It could have been anything. It could have been the letter Z, right? Now when we run that, it is in fact what it's going to print out. My name is Slim Shady. What if we wanted apostrophes around it? Well, backslash apostrophe, backslash single quote. And then back at the end, also backslash apostrophe. So now to print out my name is Slim Shady with single apostrophes. And so it did. My name is Slim Shady, single apostrophes. Well, what if we wanted tabs, right? You want a tab before the word Slim Shady for some reason. I don't know why. But backslash T is a tab. So when I run it, it says my name is tab Slim Shady. What if I want to go to the next line? My name is backslash N Slim Shady. Backslash N. New line. When I run it, now it says my name is, and then it skips to the next line, Slim Shady. I still have that trailing apostrophe back there because of that thing. And lastly, what if I needed a slash in here? Like, what if my name is equal to 2/3? My parents are really weird, right? Or what if my name is 2 over T? Of some strange rapper named 2 over T. I don't know what that means. But I'm even weirder and I wanted to use a backslash there. So 2 backslash T. Well, that's a syntax error now. If I really want to print this backslash appropriately, I'm going to add a second backslash there, and that will fix it. So backslash backslash is the escape sequence to print out a single backslash. Kind of weird, huh? But if I run it, it is now going to print 2 backslash t, because it treats that backslash backslash as a single backslash, just like backslash double quote printed out a quote, backslash t printed out a tab. Run it, and that's what we see. My name is 2 backslash t. I'm kind of missing the double quotes, so I'm going to come back and add those. My name is backslash double quote 2 backslash backslash t, and then one more backslash double quote. Something happened wrong there when I typed that. I put it before the t apparently. So after the t but before the end quote, backslash double quote, right? So that's going to be translated into a double quote, that's going to be translated into a single backslash, and that's going to be translated into a double quote. So it's going to print my name is, and it's going to have double quotes around the output. My name is quote 2 divided by t, end quote. I don't know. Maybe that's the name of a Star Wars robot, right? 2/t, whatever. What is an escape sequence? An escape sequence is a backslash which sets it to go in a special mode, followed by another character. That other character tells its behavior what it's going to do. Why is it called an escape sequence? Because it's escaping the normal mode of text processing to do something new. Primitive variables versus reference variables. If you have a variable that begins with a lowercase type, it's a primitive value. int, lowercase I, right? Lowercase I. Long, lowercase l. Float, lowercase f. d, lowercase w. Char, lowercase c. All right, those are all primitive types, meaning that they are pure numbers. Purely numeric data type. But a char isn't a number? Yeah, it is, right? I showed you how capital A is equal to 65. So char is a numeric data type. What does that mean? It means that they have no methods attached to them. If I go back to my code and I type here ch dot, trying to get a list of methods that are attached to the character, there are none. But what if I make a string, right? String s, and then I type in s dot? There's a whole bunch of methods, right? That's because the s variable is of type string. String is a class, so it is a reference type. This is a reference to a string. Now, quite often when you're talking about it, you'll just say s is a string, right? Well, really, s is an object. No, it's not. S is the address of the object, right? There's an object out in memory, and S contains a reference to the address where that string is stored. Now, it's kind of a subtle difference, and we'll get more into that later on. But this is not the object itself. Just like my address is really not my home, or my name is really not me. I could change my name, right? And it's still me. Or, maybe I mess up on my address, and I add a 0.5 to it. The mailman still might be able to find it. The address is, slightly different, still the same home. Or you have 2 different street signs pointing to the same street. Doesn't matter which street sign you're looking at, it's pointing to the same street. I hope that kind of makes sense. This is a reference type. This is a primitive value, primitive type. You can see that they're even colored differently, right? That's blue, that's black. If the type begins with an uppercase letter, it's not a primitive type. It's the fastest way to tell them apart. What is a primitive type? It's a reference to a class. String is a class. We've seen other reference types. We've seen scanners. If I come up here and add an import for java.util, import java.util.*, then I can bring the scanner in. Well, scanner is a reference type, right? We've created scanners before. Scanner with a capital S, SC equals new, scanner, parentheses, system.in in parentheses, semicolon. And now if I type in sc dot, I get a list of all sorts of methods that are part of that scanner class. So scanner is a reference type because it's a class. Reference variables are more complex. They hold data. They can hold multiple pieces of data. And they hold references to the methods that use that data. Calendar happens to be a class that comes with Java. String happens to be a class that comes with Java. You can write your own classes. String manipulation. Create a string called S1 and you set it equal to goodbye. You create a string called S2 and you set it equal to hello. So S1 is equal to goodbye, S2 is equal to I say hello, and then so we say S1 is now equal to you say plus the prior contents of S1, which was goodbye. So now it says you say goodbye. And then we're adding something to it again, but this time we're appending rather than assigning. So it's going to say you say goodbye, comma, and then it's going to tack on the contents of S2. And when I say tack on, the official term for that is concatenate. So it's going to say you say goodbye and I say hello, and finally it's going to add a dot. Trace the above code. All right, sure. S1, tab, tab, S2. S1 doesn't have a value. S2 says, and I say hello, right? Next line, S1 is equal to goodbye. Next line, S1 changes to equal the words you say concatenated with S1. So S1 is changed to say you say goodbye. S2 has not changed yet. S1 changes again. Whatever S1 was equal to gets added. Now, comma is appended to it, followed by the rest of that. So it says, you say goodbye, comma, and then it takes the contents of S2 and appends that to it. And I say hello, end quote, and then lastly concatenates that period to it. Like that. Then it prints out. And if you don't know, that's a Beatles song. You say goodbye and I say hello. String methods. There are methods that are attached to strings that are part of the string class. You want to find out what's at position 2? You can print it out. Okay, what's position 2 mean? And back to our code. So, string name equals double quote shady end quote semicolon. Well, that is character 0. Computers start counting at 0 rather than 1. That's index 0. That S. That's index 1. That H. Index 2 is the A. Index 3 is the D. Index 4 is the Y. If I put a comment here, that's position 0. That's index 0. Excuse me.